So let's get started. Let's first of all start off with just a very brief introduction to web services. And first of all, let's think about what a web service is. So here's a couple of definitions from common sources that you might think of if you're trying to figure out what something is. Wikipedia says a web service is a service offered by an electronic device to another electronic device, communicating each other via the World Wide Web. And obviously, those devices are running some piece of software, essentially. It's a way, essentially, of a piece of software communicating with another piece of software. We all know what the World Wide Web is. It's a person operating a web browser communicating with something via the World Wide Web. So a web service is kind of imagine like it's the web browser for another piece of software. So it's application-to-application communications or device-to-server communications. And usually there's no human directly involved. The World Wide Web Consortium says it's a software system designed to support interoperable machine-to-machine interaction via a network. So there's nothing new here. We were all doing this in the 90s and the late 80s. You know, back then we'd call it remote procedure calls or remote method invocation, or depends what environment you were in. But essentially, you know, for us old guys, and I count myself in that category as well, it's a remote X-call mechanism over a network, is essentially what it is. It's kind of like XF Server Plus, but it's an open thing. It's not a dedicated custom client piece of software using a dedicated network protocol. It's a remote calling mechanism that uses open standards and open protocols that anybody can participate in. And that's the big point of a web service. Ideally, you're going to be writing this thing so that it's open and accessible in many cases. Depends what you're using it for. It might be a totally closed private thing. But even then, you'll tend to use open protocols to implement the service. So in terms of visualizing a web service, it's actually a real simple thing. There is a server, as the name suggests. That server is generally running a web server application, IIS, Apache, something like that, or some piece of software that's posing as an HTTP server. It doesn't necessarily need to be an actual web server product. There are ways of what's called self-hosting in other kinds of applications. But generally speaking, web services are hosted by web servers, just like websites are. And it might well be that a web server is hosting both a website and a bunch of services. That's a fairly common thing too. And then there's some kind of client device out there, whether it's a piece of software running on a computer, whether it's something running on a mobile phone or a tablet. More and more often these days, you know, with what's called the Internet of Things, more often it's just some gizmo. You know, it's your refrigerator. It's your central heating thermometer. It might be Alexa, it could be Siri. Those are the sort of things that could well be the clients to most web services these days. A web service is a very simple thing, especially a RESTful web service, okay? In particular, a RESTful web service. An interaction with a RESTful web service involves some client sending some request to some server. That server does something, whatever it does, and it returns a response. That's it. Very simple. It's a one-shot deal. Make a request, get a response, we're done. It's very similar, not surprisingly really, because it's all based on the same technologies. It's the web and it's HTTP. It's kind of the same thing that happens in a web browser. In a web browser, you go in there and you type in www.google.com and hit enter, and it sends a request to Google, and Google does something. It formulates a piece of HTML, and it sends it back to you, and the browser says, thank you very much, and interprets and displays it, and you're done. And the little gizmo in the top corner stops spinning, and that indicates you've reached the end of the request, and that's it. You are no longer connected to that server. That's how the web works. That's how browsers work. That's how web services work. Now, beyond that, some technologies, older technologies typically, may extend those mechanisms and play tricks to make it look and feel like you're still connected to the server, and you make another call and it still knows who you are and it still knows what you just did and so on. But those are things that are application specific, that have been implemented by whatever that application is. And there is no physical connection between the client and the server beyond the end of that response. But in software, they're making it look like there is and feel like there is, and making it continue by keeping some sort of state somewhere, or passing tokens backwards and forwards, or the server sending a cookie to the client, and the next time the client calls, it sends a cookie back to the server, and the server says, oh, it's you. I know about you. You were here 5 minutes ago. but it's a new connection. Okay, and that's important when it comes to RESTful web services. Why use web services? Well, web services really give you a way of combining the best aspects of component-based development. So component-based development, when you're breaking something apart into small components, presumably for the purpose of reusing them somewhere else, or possibly even selling them as a component to some third party, offering a service that you buy my component, you install it, you interact with it, and it does stuff for you, that kind of thing. So the whole concept of reusability and deployment via the web. And the interoperability that gives you, pretty much everything can talk to the web these days, right? I've got probably 4 devices in my bag and on the table here that are all talking to the web constantly. I'm even wearing one these days, for goodness sake. So that's what web services are about. It's web services that are supporting all these little devices that we've got around here, and this laptop that's pulling mail down and all of that kind of stuff. Everything is talking to a web service. Web services also give us a great way of being platform agnostic and language agnostic. Because if you're talking to a web service, all you need to be able to do is construct and send an HTTP message and receive and understand that HTTP response coming back, and you can interact with that web service. It doesn't matter what programming language you use or what programming language they use. It doesn't matter a hoot whether they're running on Windows, Unix, Linux, OpenVMS, AIX, Solaris. You don't care. It's just an HTTP message. Okay? So the concept with something like XF Server Plus, it's like, oh yeah, we support Java and .NET clients, and you can run the server on Unix, VMS, or Windows, and we do kind of care. With web services, we don't. So the thing is totally decoupled. The client doesn't know and doesn't care and isn't in the slightest bit interested how the service is implemented or what technologies it uses, and equally, the service doesn't know or care about the client, typically. Now, that might not be the case. You might, as a developer, design an API in such a way that certain things have to match and you have to have certain capabilities over here and stuff like that. But as a general rule, when it comes to web services, that is not a constraint that's placed on your applications by the web service environment itself. It's something you may choose to do. Web services also typically, if designed well, will typically scale very well. Scale up and out and allow you to go from very small implementations to very, very large implementations, and generally give you multiple deployment options. As you'll see later, we can deploy a web service inside a web server on a number of platforms. We could write an application to host it. We could put it out in the cloud somewhere in any number of services. We could have a remote virtual machine that we host it in. We could deploy it to the Azure cloud or the Google cloud or Amazon cloud or whatever it is. So lots of different options for how these things can be deployed. And generally a great return on investment. One of the reasons that a lot of our customers get into these things for the first time is the return on investment is so good because you implement the server or the service one time. And once you've got the service, you can start hitting it from anything you want. So a lot of times, if there's a major new development of something going on, whether it needs that remote aspect initially, I and many people will always kind of think web service first and design new APIs always around a web service, even if maybe I don't need it today, but it'll sure help me down the line if I decide I want to introduce a mobile application in a year's time, or I want to put a web portal onto this thing, or I want to build a dashboard for this thing at some point, and I want to start having multiple clients all hitting the same set of back end. So web services are really great for that. So what accesses a web service? We've pretty much covered this in detail already. Software applications access web services, or software applications built into devices more and more often. So, yes, desktop apps, server applications, websites, other web services. I wrote a web service a couple of weeks ago that I needed to consume some publicly available information, so I just Googled it, found a web service, and in my web service I call another one to go get some data on zip codes in a state or something like that, I think it was. And very often mobile applications. If there's any concept of one of these guys talking to something out there, if it's anything but a totally local application, which very few are obviously, then there's a web service involved somewhere. More and more devices, Internet of Things, the refrigerators, the smart home components, all of those kind of things. And basically anything where you want to interact via a published API. You just want to publish an API for something and let people come into that API and use it either for free or you make a charge for that. There's lots of organizations out there, or lots of websites out there, who are simply in the business of publishing web APIs and charging you to use them, and exposing all nature of data and algorithms and so on. How are web services called? Web services are called, as you can probably gather from the name web service, by ubiquitous web protocols. So HTTP, or in almost all cases, really beyond simple development and testing, HTTPS is what you need to be doing when you're deploying web services. Occasionally, there are ways of supporting other network protocols if you're in a local area network scenario only, and you want to do something that performs a little bit better than HTTP perhaps. There are some ways of using other protocols, but a very, very high proportion of web services use HTTP or HTTPS. And also using ubiquitous data formats. So in the old days, again, we've already mentioned that would mean XML. Very often it would mean that protocol on top of XML called SOAP. SOAP, if you're not familiar with it, stands for Standard Object Access Protocol. So it's a way of constructing requests and a way of constructing responses that is standards based, and people write clients to SOAP, and there's all kinds of tooling available. That's how the older style of web services, ASP.NET web services, WCF web services, they were all built on those SOAP technologies. More often, again, as I mentioned, these days, it's JSON, and we'll take a look at what JSON is in a little while. Primary use cases for web services, again, we've already mentioned this might be something that you're using simply for a private API. Private doesn't necessarily mean it's on your private network. It could still be something that's talking over the internet, but it's not sort of open to anybody to consume. So, you're building a mobile application and you're hosting a service that's going to talk to it, and only that mobile app is going to talk to that web service, and so on. So that's kind of the concept with a private API. So part of an overall solution. But also, as I mentioned, there's quite a lot of web services out there that just offer public APIs. Some of them are free. Some of them you pay for. What's a good example? Sending SMS text messages is a good example. It's often the one that people get into first. You want to send a text message from your application, so you subscribe to this service online. You pay them, I don't know, $100 for 10,000 messages, and when you're done with your 10,000 messages, you pay them another $100. And it's a simple call to a web service to say, send a text message from this number to this number with a piece of data, and off goes the text message. Sending faxes is another one that people often get into, looking to replace those older on-site faxing mechanisms. Any number of things. Here's a little bit of history. So developing web services, obviously in .NET, which is where all of our focus is because of the tools we're in and are available to us, there's really been a progression of support for web services in the .NET world. The first generation, as I mentioned, was something called ASP.NET web services. And these were introduced right at the beginning of .NET with Framework 1.0 in 2002. And they were very simple in nature. You would write an ASMX file that had some code behind in the file, and you would write methods and attribute them as a web method, and you would design the interface in that way. And then tooling would generate web service definition languages, and that would basically describe the SOAP syntax that was required to call the web service. It was a very simple environment. It worked well. It was somewhat limited in what it could do, and typically performance wasn't that great, but it was pretty easy to get up and running with. That in the .NET world was kind of superseded back in Visual Studio 2005 when WCF was first introduced with Framework 3.0. WCF did pretty much everything that the original ASP.NET web services did, but also brought a whole new bunch of stuff. WCF was heavily configuration based, and you basically didn't have to worry too much about how the code was going to be hosted or where it was going to be hosted. You would just write some code and then do a lot of configuration to mount that endpoint where it was going to be consumed. WCF also had support for a lot of different, more complex data types, and in particular for using different network protocols. So WCF had a lot of options for using things like raw TCP/IP sockets, or even shared memory on the same system or within the same local area network. So there was a lot of things you could do with WCF over and above what you could do with ASP.NET web services. But essentially it was still a SOAP-based environment that produced a WSDL, and you downloaded the WSDL and it generated a whole bunch of code for you and so on. There was, in the later versions of WCF, support for early implementations of REST, but it always felt kind of shoehorned in and never really worked that well because WCF was designed around SOAP, essentially, and REST is totally different to that. So there is a thing called WCF REST. If you've got a lot of WCF stuff and you want to get into a bit of REST, you can do it with that, but it's not very pure. It's kind of shoehorning the old stuff in to look like it's the new stuff. This is not brand new. Web API started back in Visual Studio 2010, and then it changed to the version 2 of, or the current version of, is 2.2 actually, but Web API 2 is what it's referred to as a major extension to Web API. And that goes back to December 2014. And this, I would say now, is the premier way of developing web services in the Microsoft world. It is totally focused on REST web services, so if you need to be SOAP-based for some reason, WCF is still your guy. So Web API is really focused on being a RESTful web service, and personally I think it's the best Microsoft have ever done in this environment. It blows all their previous attempts out of the water, in my opinion. It's simple, it's easy to use, it's very, very fast. When I first started getting into this, Microsoft were making claims of doing big performance testing against all of the other leading web services frameworks. And I think back in the day, they were claiming that they were the second fastest. I forget what was above them. They did lose some ground somewhat in the last couple of years and recently announced that they're now refocused on really tuning this thing and they're shooting for #1. So some of Microsoft's web services technologies don't have a great reputation when it comes to being, fast and scalable. Web API really is the difference. It's a whole new world from what they've done before, and it really is superb. By the way, if you've done web development, the latest and greatest Microsoft environment for building websites is what's called ASP.NET MVC, okay, Model View Controller. Model View Controller, you've heard us talking about MVVM for a number of years as a way of constructing structured desktop applications where you have models and view models, right? So the model is the data, the view is the UI, and the view model ties the two things together, and it's all about separation of concerns. It's all about that business logic being totally separate from the UI and being totally separate from the database access layers and building applications with those different layers so that you can swap those layers out and interchange them and so on and take that UI off and put a new one on in a few years' time, that kind of thing. MVC is the same thing for the web. Okay, they call it, instead of model view model, it's model view controller. The controller and a view model are pretty much the same thing. They do a very similar role. So MVC is the structured way of doing web development, and Web API is very, very closely related to MVC. It really works the same kind of way. It's really kind of like MVC, but without the V, the view. We deal with models and controllers. So models define data, controllers define the operations of the web service. So ASP.NET MVC and ASP.NET Web API really are closely related, and you work with them in a very, very similar way. So that's kind of a brief overview of what we're shooting for. That's what we're going to be trying to do today.